Now let's see what we have in store. Of course, the best way to learn these concepts is to apply them. So let's see what we have further. Let's take some example. Say a man takes a loan of 100,000 repayable in 5 equal yearly installment, interest it at 12% per annum. So interest rate I is going to be 0.12 compounded annually. Find the total interest and yearly installments. So he's taking a loan of 100,000 correctly. So he is taking a loan of 100,000 repayable in 5. So from today in future for the next 5 years he is paying the amount or the installment. How should he be paying on at the end of every year? So current value is 100,000. So we are going to use the present value formula. It's going to be R upon I into 1 plus I raised to n minus 1 upon 1 plus I raised to n. So we need to find out R. So it's going to be 100,000, which is going to be the present value. R is something we don't know. I is going to be 0.12 into 1.12 raised to 5 minus 1. The numerator has 1.12 raised to 5 minus 1 and the denominator has 1.12 raised to 5 itself. So how is it going to be? R is going to be all this thing. So how can we do? We can first find out 1.12 raised to 5 minus 1. So it's going to be how we have is 1.12 into 2 times, 3 times, 4 times, 5 times. So this turns out to be 1.762 odd and minus 1, 0.76234 and odd. So this itself turns out to be this much amount, 0.76234 and so on. So what we do, we can put this in the memory. Okay, so that much you got. Now what we need to do is we need to multiply this as well as this. So we start with 1.12 raised to 5. So we have 1.12 into 2, 4, 5. That into 0.12 into 100,000 and this we divide by what we got in the memory and you get 27,740. So R turns out to be 27,740 rupees 97. So we can take it as 41 rupees. 27,741 is the annuity that he pays at the end of every year. Now we need to calculate the total interest and yearly installment. So the yearly installment is 27,741. Now the interest is how much you're making. So it's going to be R into N. So which is going to be, we are making so many. So R into N, which is going to be 27,741 into 5. So which turns out to be some 1,38,704 or maybe 5 or something. This is the R into N. And interest is going to be nothing but R into N minus P, which will be 1,38,705 minus 1 lakh, which turns out to be 38,705. That means whatever is the present value of 1 lakh turns out to be 1,38,705 net over the period. So that means the interest that you're paying is actually 38,705 and the annual installment that you're paying is 27,741. So this is how we do this kind of sum. So identification of whether it's a present value or future value solves major part of the entire problem. Okay. From this example, we have another. So we have a formula here. Future value of an ordinary annuity is what among these? So A, this is a symbol given, A n comma I. That means A for how many years and what is the interest is equal to what? So which among these could it be? We know that the formula is A. So we know that A is equal to R upon I into 1 plus I raised to n minus 1. Now here apparently throughout this A, the A over here and the A over here are different. This is a future value and they have taken this itself as this A over here is equivalent to R. So don't get confused. So among these, it's definitely not this. It's not 1 minus either. It's not this either. So it's going to be, this is what we have here. R into 1 plus I raised to n minus 1, the whole divided by, which is the same as R into this upon I. So hence this is the correct answer for the future value. Okay, right. Okay, now let's take this example. A is equal to rupees 1200, n is 12 years, I is 0.02. What would be V? Right? So that means what is the present value is what they're going to ask. So it's going to be, the symbols used are different. So they are using the formula they given as this. So V is equal to A into, so it's going to be A by I into 1 minus 1 upon 1 I raised to n, which can also be written as A by I into 1 plus I raised to n if you take the LCM minus 1 upon 1 plus I raised to n. So this is the formula. So they have asked what is the formula, what is the value of V, right? So V is going to be what? 1200, which is A, 12 years. So it's going to be and 1.08 raised to 12 minus 1 upon 0.08 into 1.08 raised to 12. Here there is no minus 1 factor. So what do we do here? We have 1.08 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can just note it down so that we need have to do that again. So 1.08 raised to 12 is going to be 2.518,170,11679. Okay, and this minus 1 into 1200. We have 1821 divided by 0.08, and this you have to further divide it by 2.518,170,11679, which turns out to be 9,043. So this V turns out to be around 9,043 rupees 30 paise and odd. So that means, what does it actually mean that depositing 1200 over a period of 12 years is amounting to having 9,043.30 rupees with you right now. That is the net value of all these deposits with reference to the current time framework. So among these we have this, none among these, so it has to be none of these. So that is the present value. So this V is what we have been calling present value, right? Hence we have that. Okay, let's check. All right, fine. 9,043. Okay. Now here you have A is rupees 100, N is 10. I find the future value. Future value, when we don't take this into account, we have future values. A is nothing but R upon I into 1 plus I raised to N minus 1. So R upon I, R is of course we have 100 upon rate is 0.05 into 1 plus 0.05, that is 1.05 raised to n, that is 10 minus 1. So this is what we need to find. So how do we go about doing? 1.05 into twice 3, 4, 5, 6, 7, 8, 9, 10. So it is 1.62 whatever minus 1. So we have 1.05 into 10 minus 1 into it turns out to be 1257.79 paise, which is roughly 1258. So among these, this is the right answer, 1258. Let's check it. Yes, right. So these examples are directly given the formula and you just have to substitute just as a warm-up. Furthermore, we have find the amount and PV of 5-year installments of 10,000 each. So there are two assumptions, that is we need to find the amount. Suppose you're making 10,000 rupees right now. From today you're paying. After 5 years, what will be its value? And currently, what will be the value of all these 10,000 projected over 5 years? What will be the equivalent present value? So we are going to use two different formulae. So for both of them, R is going to be 10,000. Suppose yes, I is going to be 0.1 and n of course is 5. So let's calculate rate. We have to find out the amount and present value. So we're going to use A is equal to R by I into 1 plus I raised to n minus 1. This is one thing. And P is equal to R by I into 1 plus I raised to n minus 1 divided by 1 plus I raised to n. So let's calculate both these amount. So here you have, hence this will turn out to be 10,000 upon 0.1 into 1.1 raised to 5 minus 1. So let's see what you have. 1.1 into 2 times 3, 4, 5 minus 1 into 10 and it turns out to be 61,051. This is the future value of these deposits. Now we need to find this. If you see, we already calculated this part. This can be simplified. Since it's the same set of values, you can write it as R into 1 plus I raised to n minus 1 upon I, which is what you calculated now, into 1 upon 1 plus I raised to n. Since it's the same value, this alone is 61,051. So this is, you're going to divide it by 1.1 raised to 5. So it's going to be 61051. It works out to be around 37,907 rupees 86 paise, which is approximately 37,908 rupees. So just to reiterate what is said, depositing 10,000 now in 5 equal annuities what is this currently? What is the value of this? It is 37,900. What is the value of all this at the end of 5 years? It is 61,051. So we are using, it's a good example to make you understand both the concepts together. Okay. Right. Okay. Furthermore, yes, we have 61,051 and 37,098. Okay, now here we have an interesting, given annuity of rupees 100 amounts to 3137.12 at 4.5% compound interest. Number of years would be what? So you have to find out after how many years will this 100. So what formula will you use, the present value formula or future value? Now he's talking, it's being told is about it will amount to something in the future. So obviously it's a case of future value. So it's going to be, we need to have A is equal to R upon I into 1 plus I raised to N minus 1. Now out of these, we know this is 3137.12. R is 100 because the equal amount deposit is this upon 0.045. And here we have 1 plus 0.045, so 1.045 raised to N, which is going to be, we don't know, 1.045 minus 1. So how do we do this? This is the same as selling 3,137.12 into 0.045 upon 100, you're cross multiplying, plus 1 is equal to 1.045 raised to N. This is what it will amount to. Hence, let us calculate this. Is 3137.12 into 0.045 divided by 100 plus 1. So that means it's around 2.411704 is 1.045 raised to N. So we need to see how many times 1.045 has to be multiplied by itself to get that. So let's see, 1.045 into 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So when N is 20, then 1.045 raised to 20 turns out to be around approximately 2.4117 odd. So obviously N is going to be 20. So the number of years is 20 approximately. Right. So we get it as 20 years. And yes, we do have it there. Okay. Then now, the present value of an annuity of rupees 3,000 for 15 years at 4.5% per annum compound interest is so and so. So, here we need to find the present value formula. Let's recap what the present value formula is. So, P is equal to R upon I into 1 plus I raised to N minus 1 upon 1 plus I raised to N, which turns out to be R. Now what things are known over here? Present value of an annuity. So it's 3,000 upon interest is 0.045 into 1 plus 0.045, 1.045 raised to 15 minus 1 upon 1.045, hence raised to 15. So since this is a common factor, we can just note it down. 1.045 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it turns out to be 1.045 raised to 15 turns out to be around 1.935282443. This is just to avoid, you can note it down so that you need how to multiply, you can save time on this. So minus 1 into 3000 divided by 0.045 divided by 1.9352824443, and you get roughly 32,218 rupees 637 or 63 paise. Hence the present value of all these deposits, and actually the amount that you deposit is actually 45,000. So what 45,000 you net deposited over 15 years is equivalent to just 32,218.63. And among these, this is the right answer. Okay, fine, we will have it that way. Okay. If the amount of an annuity after 25 years at 5% per annum compound interest is 50,000, the annuity would be what? So what is it? The amount of an annuity. That means you are depositing some amount now. Yes. What will it become? It has become 50,000 after 25 years. So we are not going to use present value formula. We are going to use the future value formula, which is going to be A is equal to R upon I into 1 plus I raised to n minus 1. But watch it, we need to find out R. So let's substitute the value. So this amount that it amounts to be is 50,000 is equal to R upon 0.05 into 1.05 raised to 25 minus 1. So we need to find R, which is going to be 50,000 into 0.05 upon 1.05 raised to 25 minus 1. Now, let's see what this turns out to be. So we have 1.05 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 17, 18, 19, 20, 21, 22, 23, 25. Right? We are going to take this minus 1. We store it in memory. Okay, so that goes into memory. Now, what we need to do is 50,000 into 0.05 divided by whatever we have in the memory, which turns out to be 1,047 rupees 62 paise. Roughly around 1,047.62. So the deposit that you need to make at the end of every year, which will amount to 50,000, is 1,047 rupees 62 paise, which is among these none. So none among these is the answer. This is quite close, but the difference is more than 1 rupee. So 1047.62. So we get 1047.62, which means that you need to deposit 1047 rupees 62 paise every year, so that it would amount to 50,000 after 25 years. Okay, so none of these. Furthermore, the amount of an annuity is certain of rupees 150 for 12 years at 3.5% per annum compound interest is so and so. The amount of an annuity is certain of rupees 150 for 12 years. That means you are depositing 150 rupees every year. So after 12 years at this rate, what will it turn out to be? So obviously, let's see what will turn out to be. Oh, if it's going to be, R is going to be 150 and N is 12 and I is 0.035, and we need to find A, which is R upon I into 1 plus I raised to N minus 1. which obviously will turn out to be 150 upon 0.035 into 1.035 raised to 12 minus 1. Right, so we need to calculate 1.035 and 1.035 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1.5 and odd minus 1 into 150 divided by 0.035. It turns out to be 2190.28 or 29. So it amounts to this. So the closest is this among these, 2190.28. So our option is 2190.28. Okay. All right. Then the present value of an annuity of rupees 80 a year for 20 years at 5% per annum. So we have present value formula, if you remember. P is equal to R upon I into 1 plus I raised to n minus 1 upon 1 plus I raised to n, which will turn out to be, we need to find the present value. R is 80 into 1.05 raised to 20 minus 1 upon 0.05 into 1.05 raised to 20. So let's calculate what is 1.05. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 20. So it turns out to be, that is 1.05 raised to 20 is equal to 2.65329770,502. Okay, and this minus 1 into 80 divided by 0.05 divided by 2.65329770,502. Turns out to be around approximately, P turns out to be around 996 rupees 97 paise, which is approximately 997 rupees, which means depositing 80 years for 20, 80 a year for 20 years, actually 80 into 20, 1600, right? But the value of the 1600 presently is actually 997. So hence the correct answer is 997. Okay. Further ahead. Alright. Now we have a loan of rupees 10,000. Let's move this. Is to be paid back in 30 equal installments. So currently the value of this is 10,000. The amount of each installment to cover the principal and at 4% per annum compound interest. So what do you have? Present value is 10,000 and n is 30, I is 0.04. Right. So you need to find out R is what? So P is equal to R by I into 1 plus I raised to n minus 1. So P is turning out to be 10,000 is equal to R, we do not know, 1 plus I raised to n, that is 1.04 raised to n. N is 30 of course, minus 1 upon, there is of course a 1 plus I raised to n factor upon 0.04 into 1.04 raised to t. So let's see what we have here. 1.04 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1.04 raised to 30 is around 3.2439750983. Now we need have to write this down. You can do it again, but just to save some time. So you do this numerator, you calculate it, store it in memory, you can do that. Then 10,000 into 0.04 into 1.04 raised to 30, which will be 3.24 339750983 divided by roughly turns out to be around 578 rupees. So R turns out to be around 578 rupees odd. So we get 578 roughly around 578.30 we are getting. And the closest among these is this. Sure, this will be the answer. Yes, we do have it back. So this way we straight away substitution of the values. Okay. Now, here we have how much amount is required to be invested every year so as to accumulate 3 lakh at the end of 10 years if interest is compounded annually at 10%. So obviously it's a case of future value. So the future value, that is amount, is turning out to be R upon I into 1 plus I raised to n minus 1. And you need to find out R. So it turns out to be 300,000 is equal to R upon 0.1, which is the rate of interest, into 1.1 raised to 10 minus 1. So ultimately R is going to be 300,000 into 0.1 upon 1.1 raised to 10 minus 1. Now this obviously will turn out to be 30,000 divided by 1.1 raised to 10, which is 2.5937 minus 1, 1.5937. So let's see what this turns out to be. Wherever it is not essential, when values like these are given, you can straight away minimize the usage of calculator. 30,000 divided by 1.5937, which turns out to be 18,824.212 or something. So 18,824.12, which doesn't seem to be any among these. So this seems to be the correct answer. Let's see. So we get 18,824.12, none of these. Yes, that's what is the right answer.